Hello everybody, ODAT Nerd here, aka Terrence. This is the pre-recorded video that is going to play at the start of every Devember video. So what day is it? If you're watching this on the day that I recorded it, probably a day in December. What day? I don't know. I'm not creating 31 of these things. This is to tell you that we are working on the Devember project, which is a remote build system in Sublime Text. Now, down in the description, if I have done my job correctly, there should be a link to the playlist that has all of the videos in this series, which starts with the video that describes what the heck it is we're actually trying to build here. And this video will be a minimum of an hour long. I don't know how long it's going to go because I haven't recorded it yet. It's still November right now while I'm reading this to you out of my brain. That's not actually written down anywhere. I think that's probably easy to tell. I'm not very good at talking off the top of my head into a camera. So what are we going to be doing tonight? Don't know. Hopefully working on something really interesting, though. Probably should have thought that through a little bit more. In any case, we're going to go ahead and say the following. If you like these videos and you want to know when there's going to be more of them, subscribe to the channel, link in the description. If you're interested in videos that aren't live in nature, there's another channel I have that is going to be providing those. I have in the past and I will again. I'm just not right now because I'm doing this every day for December and it's taking up all my free time. Link to that is in the description. Like any videos that you find useful, comment on any videos if you have any questions, and most importantly, have a good time. So let's go ahead and give it to myself in the present, if you will, to continue on faceless because I don't have the sort of setup that allows me to stream my face while I'm working. All right, hello everybody. Welcome to Devember day 2. And let's recap what happened last night after the stream was done, just so that you can know what the process has been so far. This is the stuff that was in that view yesterday. And what I actually did was flesh out my idea for how this should work a little bit last night based on my working out of things over here. But I wasn't particularly happy with that. Now, today being a weekend day, I woke up stupid early, had to do various weekend tasks, which included my long morning weekend walk where I did some design in my head on how I wanted the our networking to work. And I think I've come up with what I think is probably the way to go. So what's in here isn't that I checked in last night isn't necessarily what we're gonna go for. It's kind of similar to that, but I did not like this whole you have to define a constructor and it has to do something special. That's just excuse me. That's just dumb, if you will. So I thought about this, and as my general plan when I'm thinking through problems, design problems like this, I like to do it while I'm out on my morning walk, which I do every day, but the weekend ones are a little bit longer. And if you walk the same route every time, everything gets to be rote. You can really sort of disconnect your body and just think about various problems. And excuse me, got a little bit of a tickle in the throat there. You can really I find anyway that I can think through ideas in a way that I can't if I'm uh, actively thinking too much about like sitting in front of the computer and typing things and whatnot. So I've come up with I came up with an idea, and then earlier before the stream started, I sat down and sort of fleshed out how I thought it would all work. The other thing I learned is that I really need a USB 3 method for getting footage off of my camcorder because it take a ridiculous amount of time to just get that short 10-minute clip off of the camera at 1080p, and factoring in also the very brief editing for the vlog just to throw the title on there, and then rendering a 1080p file to another 1080p file using the exact same encoder took a while, and I use Camtasia for that, and it has problems with actually uploading directly to YouTube. They run into rate limit problems. So unless you do it early in the morning, it's not going to work. And I wanted to get it done last night. That was a whole big thing. Anyway, let's go ahead and jump on into this. As I said, I've already been doing some stuff here. And so first of all, this is the magic of things, and Sublime is quite angry because I have put this file in the top level of the package, so it's trying to load it, and it doesn't know what a thread is. So maybe if I said from threading import thread, it would be less angry. Okay. Is it saying thread is not allowed now? No, it's good. Okay. That's just because something down here is actually subclassing that. So let's talk about the plan that I came up with for our system. And I also wanted to clarify something as well. And that is when I said last night that there are a lot of libraries that I could probably be using, networking libraries to do this, but I didn't want to use them because I want to learn socket programming in Python, even though I already know socket programming in C, which is where I've been doing it for a long, long time. Um, the point of that, because of course, if I wanted to learn how to do it, I could learn how Python libraries that are commonly used do that. But that's not what I want to do here, and it goes back to when you're doing game development. I believe it was Chris Delion who does Gam Keto. He's Gam Keto on Twitter. That is an advocate for game development and whatnot. He has mentioned several times that although Unity as a game development tool and a game development engine, with its own built-in IDE and everything, is an absolutely stellar tool that allows you to quickly prototype a game and get things going, drop in your assets, script things. You can really get going quickly. He doesn't he used to in the past when he was training people to be game developers use that tool as his way of introducing people to game development. And what he found was when you use Unity, that abstracts away all of the concepts like there's a game loop and you have to worry about how long a frame takes and you have to worry about how to render things and all of that stuff that it just takes out of the equation and does for you so that you can focus on creating your game. You can just drop in your images. You can say this control does this, that control does that, and everything's sort of pre-wired and quote unquote just works. What makes it a fabulous tool for being a game development tool makes it a terrible tool for learning, because when you have a problem, you have absolutely no idea, if that's all you've learned, what the problem is. So you would have a problem with like frame timing, and that's never something that you had to deal with yourself because you've always used a tool that does it for you. How do you even know how to diagnose that? You don't really, and you could go and Google, but when you Google things, you're probably going to find answers that are using terms that maybe you're not familiar with because you never learned that, you did something else. And I am applying the same concept to this here. Yes, those libraries are probably ridiculously awesome and are going to obviate and be better than everything that I have in this file right now times 10 and just work out of the box. And I do know the concepts of socket programming, but there may be peculiarities and vagaries of them that don't work in Python that I might not be unaware of. So I want to build it from scratch myself, build it up so that from there, once I have something that's working and I know I can make it work, I feel personally much more comfortable using somebody else's library, because if I ever have to dive into that library to debug it, to add features, to just figure out what the hell's going on, I have the tools to do so. That's why I'm doing that. So I've come up with a few classes here for our design for what we want to do. And the overall goal if this is to have some system that's in place and just sitting there that our build command or any other commands that we care to create um, can call on one or two simple entry points and make more complex actions happen, right? Um, and this is actually something, while I was walking, I was trying to figure out how to solve various design issues uh, with how I was thinking of doing it. Uh, because that it's being done in Sublime in a background of another application, whereas I'm more used to creating this sort of mechanism for the actual application itself and not for a plugin in an additional application. I realized I was kind of going down the wrong avenue with that, because generally when I create a system like this, you know, in historically in the past, it's been a system that needs to keep a persistent connection open to a remote host to do something like IPC or something like that across a network. So you need to be able to put messages across, get messages from the other side, and you don't want to be screwing around with making sure that if the connection drops, you reconnect it, and how long do you wait until you reconnect so you don't hammer the network subsystem and all that stuff. You just want to say, I put a message, I got a message, I put a message, I got a message. And that's how I was trying to design this originally. And I realized that's not what I want here. What we want is, yes, an object that will sit in the background and be our sort of proxy, if you will, for all of our network connections. Um, and to that degree, you want to make sure that you can put a message and get a message, but it doesn't, and you want to keep that connection open, say between builds. You don't want to constantly build up and tear down a socket connection for every time you hit build, because possibly there's some information that could be cached in that connection. Once we send two files to the remote side because they both participate in a build, like a header file and a C file, then you just modify the C file and build again. We don't need to send the header file. The header file hasn't changed. We just need to send the one file. And so if you kept that connection open, information could be kept on what files you've given and when they were last changed, so that you can send just a subset of information that you need. We could even send, instead of whole files, patches of whole files to actually just zero in on changes and have the server apply patches to files it already has, and all that sort of stuff. You want that connection to be a persistent connection, which is, incidentally, my original plan for this was to build a server in Python and use like a web server, because those seem like it would be very easy to create a simple HTTP server. But I didn't like that the connectionless nature, the stateless nature, I should say, of HTTP, which is why I didn't do that. So the key to the whole system for us is the class that I am going to be calling the connection manager. And we can just like read the comments here and go through this. This is the class that's going to manage all of our connections. So basically it's going to be, if you will, sort of an enhanced list that's thread safe, because our client code, our commands in Sublime need to be able to interact with this class, but also the background thread doing network operations also needs to deal some with it. So it needs to be our design is it needs to be a thread safe list. And excuse me, I got a serious tickle in my throat here. So there's the two methods at the top here are startup and shutdown. Startup would be called by our plugin in plugin loaded, and shutdown would be called in plugin unloaded, which is basically what we're doing here in our original code. Whereas in plugin loaded, we set up that job queue and spin up a thread, and in unloaded, we tell the thread to stop and then join it. That's exactly what these two methods are for, only there's obviously more things that they're going to have to do. So we're going to call one of them at startup and one of them at shutdown in the plugin. Now, realistically, as I said in the previous thing, plugin unloaded is really only called when a package is ignored, which only happens when the user decides, I don't want that package anymore, or when package control decides it wants to update a package, it needs to put it in the ignored list so that it doesn't run into file issues with it updating a package while Sublime is loading it. So realistically, it's a nice thing to have. Plugin unloaded doesn't get called when Sublime quits. The plugin host just goes away. So we don't have to worry too much about breaking those connections down in a polite way, if you will. But we could do something nice in there, like actually shut down the connections and let the buffers run themselves out or something. Now, the next two methods here are the only other two public methods. Now, there may be other methods in here that will need to be implemented, maybe private methods that the network thread can use to talk back to this or something. That's going to be an implementation detail. But the two main things are, one is you can create a connection by calling connect on this, and you're going to give it a host and you're going to give it a port. And basically, it's going to create one of these objects we're going to look at next, a connection object that wraps that host and port, and add it to its internal list of connections that it knows about, and then shoot that connection object back to you to do with as you wish. Now, that connection object is you're going to be, as the client, your window, quote unquote, into the system. All the operations that you're going to do on a connection are literally on a connection object. The connection manager is just for managing the connections, right? So the other part of that is finding a connection based on possibly a host and a port, or just a host or just a port, or neither, which isn't represented here in the arguments. But notice that it says that it's going to return a list of connections, a possibly empty list. So the idea here is you could ask the connection manager what connections are currently available, because perhaps you want to talk to a particular host and port. And this would be an example of running a second build, or perhaps running a build in a second window. Because remember, and if you're not familiar with this, if we get to that part of the dev stream throughout Devember, when you build a custom build system in Sublime, you need to create a window command that Sublime will call when you run the build. And the default is to use the window command exec, which actually runs a program, right? We're going to write a command that replaces exec and seems to act like what exec does, but it's actually sending the files to another system and running them there and capturing the results and then displaying them locally as if this is where it was actually running. So a window command, there's one explicit instance of a window command for each individual window that exists in Sublime, which is why you can have one window with Python and another window with a C file active. And when you hit Control B in either one, when it doesn't keep asking you which build you want to use if you have it set to automatic or something like that, you know. So imagine that we could actually have a second window open where we try to do a build, and that build could say, instead of creating its own connection, it could just say, hey, do you already have a connection to that host? Because maybe I could piggyback on that. Now, is that a good idea? I don't know. We'll find out. But we might also want to just introspect the list of connections that's there for our own purposes. You know, as the user of the package, you might want to see what connections it currently has available. So that's what this method's going to be. Now, you can pass it a specific host and a port, and it'll give you back all the connections to that host and port, because there could be more than one. And it may well be, vital for certain communications, depending on how we work the protocol, that be the case. We don't know yet. Or you could pass it a host with a port of, say, -1, which isn't valid, and then it'll just find you all of the connections on that host, regardless of what the port is. Conversely, you could drop the host and only specify the port if you cared, just to do the same thing, find all connections on a port. Or you could not, you could pass like none and -1 for the parameters, in which case it would just give you the list of all of the connections. I'm imagining that's more useful for actually introspecting the list of connections. Now, next we move on to the connection object itself. This wraps a connection to the remote server. Now, there's obviously going to be a bunch of variables in here. Two important ones are a send queue and a receive queue, which again are very similar to what we had over here. They'll be like so, but instead of a job queue, it's a message queue, one for messages that are pending send to the opposite end of the connection, and one for full complete messages that have been read from the other end of the connection. And of course, we're also going to need a socket because this thing needs to talk. And we're going to make our socket non-blocking. And we'll see maybe we don't need it to be non-blocking, and we could do the thing I said yesterday where you can set a socket to be in a timeout mode instead of non-blocking. The three differences are blocking. You call read and there or receive and there's no data. Your program hangs until data arrives, conceivably forever. Non-blocking, you call receive. If there's no data, it immediately returns with no, there's just no data, allowing you to do something, else. At the expense of if you just sat in a loop doing that, you'd be burning CPU constantly checking the socket buffers. And the timeout method is sort of a hybrid of the two. You say receive, but with a timeout of half a second. And then you either get data or it waits a half a second, decides there's no data, and returns back to you, no, there was no data. Now, I prefer to work with non-blocking sockets in general because the worst case scenario I've found in all my years of socket programming is if you have a non-blocking socket, that your code will do something dumb, perhaps if it loses track of what it's trying to do, like trying to read a socket that doesn't have readability and there's no data there, and it maybe burns CPU like there's no tomorrow, but it's still running. Problems with blocking sockets are no matter how careful you are, there's always some small niggly possibility that you might try to send on a socket that is currently unsendable or read on a socket that's currently unreceivable. And if an exceptional condition occurs, your program just hangs, and there's not a hell of a lot you can do about that. And a hung program is less useful than one that's just consuming a lot of CPU, because in that case, at least you could potentially save your work and get the hell out of there. Whereas if the UI was just hung, that's not something you can do. The timeout method in this might actually make that not too terrible. But in any case, that's how that's going to go. And there's going to be some other variables here. We're not going to know what they are till it actually comes time to write this. We have to do things like if we're sending a message, we have to keep track of how the bytes of the message being sent. And if we don't send the whole thing, we have to know how much of it's left so that the next time we try to send, we can continue sending that message. Similarly, when we're receiving, we're going to have to receive first the bytes that tell us how big the payload is. Then we have to read the payload. If that doesn't all come in one read operation, we have to keep track separately of the data that we've read thus far, so next time we can go again. And how that all works will be something we worry about later. The init method is something that you're not going to call yourself. This is what the connection manager is going to call on your behalf to actually set up the connection for you. Now, this is the public API for this class, all of these methods that don't have underscores in front of them. So the two simple ones, send and receive. I have a connection. I want to put a message to the other side. I say, hey, send this this message, which is going to be an instance of protocol message, which we're going to look at in just a couple of minutes. All that's going to do is drop that message into a queue, or as we'll see, it'll turn it into bytes to send and drop that into a queue, and then just leave. And that's all you need to worry about. Basically, this is a wrapper on the queue put method, if you will. And similarly, receive is a wrapper around a queue get method, only it's going to be non-blocking. At least the way I envision it here. They could also add a timeout value here because the queue get also allows you to timeout stuff. So we're going to say that this is for receiving messages. It'll return none if there aren't any pending messages, or a protocol message from the queue if there are any available. And you could conceivably call this multiple times in a row to get multiple messages out of the queue if you knew you had some, which is where the next part of this comes in, which is this register method. And in the register method, this is for basically assigning a callback to say, hey, connection, when I receive a message, I want to know about it, right? Otherwise, it constantly has to poll, and that's not what we want. We like event-driven stuff. Life is just a lot easier overall. So you can give it a callback, and that callback will be invoked with the connection, maybe an event to let you know if, because events would include things like a message was received, or a connection was dropped, or an error happened or something. So maybe there's a parameter in the callback. We'll see when we get to that part. And we could also enhance this, because there could be multiple types of messages. So maybe you could say, I would like to register to receive introduction messages at this callback, and I would like to register to receive file messages at this other callback, and then you can really delegate things out into your code. We'll see when we get to that part. That'll be easy enough to add. And this is going to return some sort of value that can be passed to unregister as the key to decide you don't care about those events anymore. Then lastly, there's a close for when you've decided I don't need this connection anymore. You can ask it to close. And probably other things could close this on your behalf, like calling shutdown on the connection manager. This one here is an implementation detail, because in the network thread, as we're going to talk about in a minute, we're going to use the select call to know which connections are readable and writable. And I did a bit of research on this, not a whole lot extensively, and it seems like you can pass select either a file ID or an object with the file no method, which is supposed to return that. And I'm guessing that socket has a similar method in it, and you could probably add actual socket class to the list. So basically, this is going to be a proxy for that, so that select can select on our clients, and we'll just know exactly what client is readable or writable in the select call without having to do some sort of socket mapping, which is always a pain in the butt in C. Now, the rest of these things here are for the use of the internals of the network thread. First, this one is writable. The network threads are going to call this to ask this, hey, do you need to write anything to the other side? And the answer is going to be yes if there are messages in the queue, or when there's not messages in the queue, but we're sending a message and we haven't finished sending it yet. Those are the only cases that you need to be writable. And that's the network code needs to know that, because unless you're doing some sort of file transfer that's keeping the socket buffer saturated with data, a socket almost always selects as writable, because writable just means there's room in the outgoing socket buffer for more data to be put there to be transmitted to the other end. So put a socket in the write set, and you pretty much, your select is just going to say every socket in the list is writable, and you're losing the benefit of select. So we're going to stop that from happening by doing that. And then lastly, when the network code decides that a connection is actually has data to send, and we know that it has something to send, it'll call send on it to actually transmit the data. So there'll be networky code in here to send our messages. And similarly, when it decides it needs to read something, it'll do that in the receive. And then the last thing is the network thread, which is going to look, well, not entirely dissimilar to this. We're not going to create a socket. That's part of the connection object. We're not going to call connect. That's part of the connection object. We're not going to necessarily directly call, send, and receive, but all of these operations are going to happen inside here. So what's going to happen? Basically, there's going to need to be a while one loop, which is not something that this has. This just tries it once and quits. But as the thread that's managing all of our connections, clearly we need to be able to get all of that data going, and network operations are ongoing, right? So it needs to be a while one loop, but we need to be able to stop that loop so that the thread can gracefully terminate. So we'll have a semaphore, and at the top of the loop, if the semaphore hasn't been signaled yet, then it runs. Otherwise, it gracefully exits. And then the code in the connection manager shutdown can signal the semaphore before it leaves. So when plug and unloaded is called, the thread goes away. And besides that, it also needs to gather the list of all of the connections in the connection manager's list of connections, find out which ones care about writing, which ones care about reading, and then do a select on them with some timeout to see if any of them have any IO. And then we just call send or receive on each of those two objects, or on any object that declared that, that selected as being readable or writable. And I'm sad about this. I primarily for the last decade or more have done all of my socket programming on Linux, and in that particular case, um, the select call is nice in that if you call it with an empty list of readable, an empty list of writable, and an empty list of exceptions, and you give it a timeout, essentially it just sleeps until that timeout expires or a signal interrupts the select, which means it can very gracefully handle the case where there's nothing to select on because the list is empty. It just basically times out and then continues on its merry way. That works under Unix or Linux, but the Python documentation for select only mentions that it may not work on some platforms and it's known to work on Linux. So if it doesn't work on Windows or it doesn't work on Mac OS, we definitely can't rely on that because we need this plugin to work on all platforms. So we're probably going to have to do something else like a thread sleep or something to make sure the background thread doesn't spin. And lastly, there is the protocol message, which is an enhanced version of the thing that I threw into this at the end of yesterday's code. Now, this is, again, the base class for all messages. And in thinking about it, I'm guessing maybe there's actually a more Pythonic way to do something like this. Certainly, this pattern could probably be done with something like a dictionary or something along those lines. But in general, how it's going to work is this. There are a couple of methods that are base class only in protocol message, and then the rest are things that a subclass has to override on its own. So the first, we'll go through the actual methods that the class has to implement. The first is ID, which needs to return a number that is unique and will represent this particular message. And the next thing that it needs to be able to do is encode as a regular, okay, the ID is, I should also say, what I would call a static method. Oh my goodness. What I would call a static method, which here is a class method, so that you can invoke it without an instance, because all instances of a particular message type are always the same thing. You shouldn't have to create one just to know that ID, right? What an instance does need to be able to do is return a bytes object that encodes its state. Now, the bytes object has to first contain 4 bytes that represent this ID value, and then the rest of the bytes are just content of the message. However, this particular message wants to put in there what fields it thinks it needs, what order it wants to put them in, what format it wants to use. 100% up to this thing. We do not at all care. And it'll return that back as bytes. And then there is a class method named Decode, and the class method will take a bytes object that came from encode and do the reverse. It'll decode it enough to be able to use the constructor of this class to return a new instance, but this one was trying to do with having a data in the constructor. Now there's just a different class method for doing that very thing. So create an instance of the object, do whatever you want with it. When you put it into the queue in the connection, when you call send on a connection, that thing is going to call encode to throw that data into a queue that will be transmitted to the other side. The server does something. Eventually, we get a response from the server as bytes. And once we get a whole block of data and we know what message it's for, we call the decode method in that class and get an instance of the class back, and away we go. And the last two methods here are in the base class only. The first is something you have to do to register a numeric ID with the class that represents it, which is associating this ID value from a subclass with the class of the subclass. And this would also do some checking to make sure that it hasn't been called with the same ID twice, because that means that someone made a real boner of a mistake somewhere. And lastly, FromData as a class method is just going to take a block of anonymous data that was read from the other side. The only guarantee it has is that that block is the complete payload of a message, because remember, our underlying protocol is going to be 4 bytes that are the size of a block of data, then just a block of data. And inside the block of data is a message. So the first 4 bytes of that is the ID of the message. So this thing gets that whole block of data. It can use that information it got from the register call to examine the ID inside, figure out which class it's supposed to be for, then invoke the decode method in that class, return the result. So you can say protocol message from data blob and get an instance back out of the thing. Now, unfortunately, that's taken up a fair chunk of our stream time for tonight. I am actually going to do some coding, but I wanted to get out there exactly what the plan for this is, because this way I can presume in the next videos as we go along through that anybody that's watching knows what the plan is. This also helps me. This is actually something I do even if I'm not streaming videos. I would actually say this out loud to myself like I'm describing it to someone, because it's a good habit to get into. You know, if you have another developer that you can talk to, shoot it past them. But even if you don't, mention it to yourself, because you're in the process of discussing it, you might actually trigger a memory or something, or a thought for how things should work. This is basically what I do in my morning walk. And like I said, my real problem was knowing that, or getting over the idea that this connection, when a connection is broken, should just automatically try to connect to the other side again. That's normally how I would do something like this, because I want this connection to be persistent. But even if I do in this case, I want it to be persistent based on the actions of the user or on outside code. So it's enough to know that if this connection is broken, that the other outside code is told that the connection is broken and is then capable of making a new connection if it needs. And then it's up to that code to best determine exactly how it should go about doing that. I should also mention these calls here, set timeout and set timeout async. These are going to be instrumental in this network code, in particular in when we call register and we need to call a callback. We don't want to call that callback. This is, well, let's say it this way. What is going to invoke a callback? Probably the code that just called receive, that determined that as a result of calling receive, we don't know if we got a whole message or not. If it was a short read, we might not have gotten a whole message. If it was just enough data to get one full message, then there's one message that needs to be dispatched. And maybe if we read 16K of data and messages were coming fast enough, we might actually get multiple full messages out of that one read that we can cram into that queue. So whatever calls receive is going to be the thing that raises the notification that messages are here. That's going to be our network thread, right? Do we want the callback to happen in the network thread? Probably not, because if the user does anything in the network thread, it's going to block the thread's ability to service I/O, the same way as we saw yesterday that not having a thread in the command makes Sublime hang while the full socket operation is going. You don't want that to happen in the underlying network code. You want to rely on the fact that the underlying network code is just delivering messages. And this is one of those trickier things to do in the general case in languages like C when you're not using a library, because how do you signal back to a thread that's other than your own thread that there is actually something that you care about? Um, there are various ways around that, but fortunately for us, Sublime has the set timeout, which will invoke the callback that you provided after the given delay in milliseconds, which can be 0, which happens in the main the main Sublime Text thread, which gets it out of our network code and into the the UI thread for Sublime. And set timeout async does the same thing, but there's an extra thread running in the background, which is the same one where async events are triggered, where you would do something that might take a tiny bit of time. You don't want to block the UI, but you still need to do something. We can use one or both of these in our callback methods in order to get the message out of the thread and into a thread that can actually do something with it. And in our case, probably what that something is going to do is going to need to call a Sublime command. So we can, set timeout async and call a command in there, that callback, and life's gravy. So that's going to be very helpful there as well. Now, this is something that I was basically looking at just as a side thing. Is there a standard cat that isn't unbuffered? Because our server currently is line buffered, and I don't want to have to fiddle around with that too much. And the standard Echo server in Linux is also, I think, line oriented. It actually might not be. I tend to use it with Echo, but I think it is. But in any case, I found a command to do something with that. But what we actually want to do is, oh, did I actually have a message? Let's swap those things around. I totally left the panel in on this one. Maybe we'll just take that out for the time being. Now, there's not going to be a lot of coding in this stream, but in all honesty, there's not always a lot of coding in coding. I had to do a bit of research on how various things work in Python to make sure that this would do what I wanted it to do. I'm reasonably assured it will. I had to sit down and think about the problem. As I've said many times in the past, sometimes I just sit down and write code, and sometimes I do some planning. I don't always do those things. Well, if it's a big enough task, you want to give it some thought ahead of time to make sure you don't run into an unfortunate corner, especially where threads are involved. But that's just the nature of Devember. Many's a Devember day that I've been going where at the end of the day, even if I was coding, I have absolutely nothing to show for it because what I tried didn't work, right? Um, what am I looking for? Not that, but I will check that code in. Um, I guess just the regular doc. Oh, I think it was in the comment here. I think we're looking at struct.pack is the thing that I'm actually interested in here. That thing. This is something that I have sort of used in the past, but not a lot. As far as I'm aware, this is what you use for, as it says, conversions between Python values and C structs represented as Python byte objects, which actually I want to open in another tab because I have a question about that too, because we're sending binary data across. And we're sending binary data. We're saying that because we literally are just sending bytes. We don't want it to be interpreted as anything unless it's supposed to be interpreted as something on the other end for flexibility. Now, as I said, I've used this in the past, and basically you can give it a format string and some number of arguments, and what falls out is a bytes object that represents, excuse me, that thing. I can never remember how exactly that works, but we're definitely going to need something like that. Now, again, this is totally the sort of thing that I would like to refer to while I'm looking at code. So I'm actually going to pop this over onto another desktop as well as this one. I may have to hide the little sidebar in this one. Let's see, format, byte size, order, and alignment. Okay. C types are represented in the machine's native byte order and properly aligned. Okay, we actually don't want native order. We want network order. Wait, okay, so network is big endian. Native byte order is big endian depending on the host system. If you have never dealt with endians before, I envy you. Native size. The format. Look, I'm one of those poor souls. The format exclamation point is available for those poor souls who claim they can't remember whether network byte order is big endian or little endian. So this is telling us that network is big endian, so we use that character in our format string. Sorry, this is the part where it's saying that. I didn't scroll down far enough on this window. And this is, as they say, network byte order. The reason that, as far as I'm aware, the reason why it's referred to as network byte order is because some systems, well, Intel are little endian, Motorola is big endian. What do you do if your Motorola processor wants to talk to your Intel processor over the network? If they're using a different endian, everybody's going to be unhappy all of the time. So there's a network byte order where someone just said big endian, that's the endian to use, and then everybody uses that. Platforms that are already big endian don't have to do anything special. Platforms like Intel have to do a little bit of extra work on the end, but everything ends up working. What? Intel Itanium features switchable endianness? That's the worst thing I could imagine, and not counting things like time zones. So let's actually take a look at what we might actually do here. I would say we want a 4-byte unsigned int. Oh gosh, this is one of those things. I would say 4 bytes is probably overkill for a number of messages. Let's see, 1248, 1632, 64, 128, 256. 512, 1024, 2048, 4096, 16,834, 32,767, 65. Is it possible that we would have over 65,535 possible protocol messages? Maybe we actually want an unsigned short for the message type, but we want an unsigned long for the block of data that we're going to transmit. And we can always say that if for some reason we want to transmit more than what's the size of a maximum size of a 4-byte unsigned, like 4 billion or something. If you want to transmit more than 4 meg in one message, split it into 2 messages. Maybe that'll come back to bite us when we're transferring files back and forth. But let's also say that perhaps we want to try to optimize the protocol to not use ridiculous sizes. I mean, you could also go the other way and say that every block should be no more than 256 bytes wide, and then every message can be split 9 ways from Sunday. Incidentally, I've worked with data formats that send the start of a message in one message, 0 or more continuation messages in the middle, and then another part at the end, and they're transmitting it over UDP, the protocol that doesn't guarantee the more than one duplicate of a message might arrive, or that they might arrive in order or at all. I always considered that a protocol designed by sadists myself, but that's just me. I'm a grumpy old man. End formats are new. S size T, I'm pretty sure I don't care about that. So let's play around a little bit here in the terminal. Now it's entirely likely that all we're going to see out of this is this network.py file that I wrote. Incidentally, the plan is to try and implement this stuff outside of the plugin and then roll it in. We've seen me do that in many a live stream before, and this so is not going to be the first one of those. Lot of talking in this one. Okay. I'm going to say we actually don't need that one anymore. I didn't like that one so much. So let's say actually from struct import pack and unpack. Let's say those are the things, right? For just a second, I'm going to refer to the other monitor for this. So yeah, pack and unpack. You pass it a format. So the struct, the format is struct format v1, v2, etc. And you get, something. And you unpack format and a buffer. Oh, hey, buffer is totally a magic thing. That's interesting to know. And that's how those two things work. Now, the other thing I actually wanted to look up, as I mentioned, was a byte object, which is an immutable sequence of integers. Okay. Bytes is an immutable version of byte array. Return a new array of bytes is a mutable sequence of integers. Oh, yeah. It has most of the usable methods described in. The optional source can be used to initialize the array in a few different ways. If it's a string, you give it the encoding. Yeah, if it's an integer. The thing that I wanted to know, because I haven't really used bytes uh, objects a lot, except as in cases like here, where I know the socket is getting it and it's a UTF-8 string, so we can just decode it directly into a string that way. Um, can you concatenate these things together? What exactly is this thing? Oh, the list of. Whoa, oh, yeah, I closed that on the other monitor. Whoa, wait a minute. Really? Is that functions.html bytes? Binary sequence types. I see. That was weird. Only ASCII characters are permitted. Mutable counterpart. No dedicated literal syntax. Yeah, that's nice. They support mutable sequence operations. So what the hell is a mutable sequence operation? Those are the things that. So slicing, append. Excellent. So let's go ahead and also niddle that around. Where was the constructor for that bad boy? Are interpreted as for byte array. Returns a new array of bytes. So if it's a string, give it a coding. If it's an integer, the array will have that size and be initialized with null bytes. If it's an object conforming to the buffer interface, if it's an iterable, it must be an integer. So that can just call byte array. Is that the theory here? Okay. So let's go ahead and open this. This is going to be, as I said, our little test bed thing. So here's some stuff in main for us to see. So how would we, let's say, test and code here? And what we're going to eventually return back is a bytes object. Now let's say we want to first add a message ID to a bytes array. How would we go about doing that? Let's say we have the ID value. The message ID is, I don't know, say 50, an oddball number, 13. And we need a return value. Message bytes is equal to byte array. And as we just saw there, if the source parameter that is the first argument is an integer, it'll have that size and be initialized with null bytes. Let's say if we initialize the thing with null bytes, we're probably unhappy, right? Because then we have to try and sequence something. So let's say the message bytes is that, and then we say message bytes dot append, and we have to first append. Well, actually, we could do this probably all in one operation. Struct.pack, we're going to have to import. Well, let's say import struct, let's say. Struct.pack, the format string, and then the first item we're going to put in there is the message ID. So we'll move that up, is message ID. And let's say we're going to pass a floating point number, maybe. Is that something that we might actually do? Let's say val1 is equal to 18, val2 is equal to 22, val3 is equal to hello world with a new line on the end because we're jerks. Val4 is, I don't know, let's say true. Got to figure all the things we're going to put in here. And val5 is, I don't know, let's say 14.67 for some sort of floating point number. I'm not even sure necessarily if that's possible. So what are we going to pack in the struct? Message ID, and then we're also going to pack these values here. And we will also do that, except this one doesn't need one. So all we have to do is come up with the actual format string for that. Okay, that, this compiles at least, so that's good. Maybe we don't need to, if we're doing this all in one, then we don't need to append it. Jank. Okay, I got what we're going here. This is going to be for testing the network code, because we know struct.pack is probably going to give us a binary thing that we can unpack later. So we don't need to say message bytes byte array and then struct.pack, because, excuse me, struct.pack returns a bytes object already. Actually, we could just say the message is that, and then we could say message, let's say payload is equal to byte array, and we're going to payload dot append, and what we're going to append is a struct dot pack of something and the length of message, like so. And then we're going to payload dot append message and return payload. Now this doesn't, we actually want this to be len message plus 4. This doesn't need to be here. So here's the idea. This represents the data in the message. We're going to struct.pack those values in somehow, if we can, into a binary object aligned the way one would want them to be aligned. Then the payload for this message that we're going to transmit is a byte array, that is the number of bytes that that packed structure took up, plus 4, because we need to use the length of this thing. And here we append to the byte array the length of the message as an unsigned int, and then also the actual payload itself, and then we can go ahead and return it. Again, that compiles. So let's work backwards from this. And we actually need to go to here like so. The following meanings. The conversion between C and Python values should be obvious given their types. Okay. The standard size refers to the packed when using, that is, format characters have the following meaning. Do these things have big endian and little endian in them? Q and Q. Oh, that was a different, that was format characters. Here we go. C types are represented in the machine's native order and byte order. The first character of the format string can be used to indicate the byte order, size, and alignment of the packed data. Do we want it to be native? No. We want it to be big endian. So in both cases, the first character of the format string needs to be a greater than sign. So that's easy enough. Whoops. Theoretically, that looks a little bit like that. Now, we want that, we're specified specifically a 4-byte unsigned int for the body. And if we said an unsigned int of standard size 4 is a big I, an uppercase I for unsigned. So we'll say that. Should be enough for that one. Now, let's see what note 3 says. When attempting to pack a non-integer, if the non-integer has an index, that's okay. So that's no big whoop. May not actually be possible to shoot a double for all I know. When the standard size, the size of the packed value in bytes when using standard size. When the format string starts with 1 up, boop. When using native size, it's platform dependent. So yeah, we definitely want the standard size, so we can rely on this. Unless there's just bytes there, I assume you have to come up with your own size on those things. So what do we say? Message ID isn't going to be a 4 bytes. It's going to be a 2 byte. It's going to be a short. Now, do we want it to be unsigned so that it's a negative value? Could be a sentinel. Is there any point at which you want to know if something is a valid message or not? I'm going to say unsigned for now. So that's the message ID. Then let's say value 1 and value 2 are both, I don't know, let's say regular signed long, well, long longs are 8 bytes. We'll just say ints for both of those. So message ID, value 1 is an int, value 2 is an int. The next one's going to be a string. That's probably going to be problematic. So we'll throw a question mark in there because we don't know. Then the next one is a Boolean. There isn't actually a bool there. Oh, which is the question mark I just put. That's unfortunate. Corresponds to the bool type in C99. If this type is not available, it's simulated using a char. In standard mode, it's always represented in by 1 byte, which is exactly what we want. Okay, so we'll change this to like an underscore or something, so we know that's where that one happens. So we have a big Indian thing with a unsigned short message ID, then 2 integers, then something that's a string, then a bool, and then the last one is a floating point number, which I don't know. What do we say here? For the FND conversion codes, the packed representation uses IEEE 754. What I don't know is which one of those two, if any, .NET supports. .NET Core 2.1 floating point format, let's say. That probably doesn't tell me what I want, does it? Nah. How about we just do that? That's the wrong thing. Single value type represents a single precision 32-bit number. The single type complies with IEEE 754. Whoops, which is what that said, right? Wrong one. IEEE 754, binary 32, or binary 64. All right, so I guess probably both of them are available. There's probably a struct double that does the same thing, I would imagine. How's the alphabet work again? There it is. IEEE, okay, for binary floating point arithmetic. Perfect. That's exactly what we would like to see. So we can use either one of those. Let's say we throw it as a double because we want all the precision in the universe to measure whatever that's going to be. That's going to be a D. We can drop back into here and throw a D in there. And that leaves us with, how the hell do we interpret the string? The string is value 3. So let's go ahead and actually, I don't normally do this sort of thing, but buts. There we go. One of those, and we can throw one here. So that's going to be message ID. This is going to be integer. Value 2 is an integer. This is a string. This is a bool, and this is a double. So for the string, that never does what I want. S or P. No notes on that, huh? Represent a char star. The Python type is bytes, and there's no standard size, which makes sense because is there standard bytes in, excuse me, a little tickle again. Is there a standard size for a string? Hell no. So let's say we throw that in as an well, do we want to have ridiculously big strings? Want to have more than 256 characters. For our purposes, let's say it's an unsigned int. So for the underscore, we have an I followed by an S. And here for this, we have to say len val3, val3, len string, string. Oh, sorry. Len, what did I pick there? I picked the big I, which is the unsigned int. So I just call that unsigned, and that. So here's some sort of message content that we're going to get. We're going to hopefully pack it into something useful, and then we're going to do that. And then I guess we could say print repr test encode and see what falls out. Anything? Oh, it doesn't like that so much. Line 305. Something is not right about this. Do I not have enough of those? Maybe that's the problem. Argument for S must be a bytes object. Oh, whoops. Oh, I need to say. Ooh. Let's do this. Val3 equals val3 dot encode UTF-8. So whatever string you provide, it'll be encoded in place to UTF-8, and then which should turn it into a bytes object. Then we get the length of the bytes and the length of that thing, and maybe an integer is required, huh? It's actually mad about the second one, but this part got through. Let's move those over just so that it lines up nice. Here's what we're seeing in the console. In line 301, we're seeing that the length of the message doesn't return an int. What the hell does it return? Sure looks to me like it's an int. What am I missing here? Of all the problems I expected to have with this wasn't one of them. To be honest, I'm not sure where to even go with that. Here. Let's copy that part out and throw it here. Just to do that. And well, we just an integer is required. Oh, is that why it's getting mad? Huh. Well, let's go ahead and go back to bytes objects then. Byte array objects. Create an empty instance, 0 field from an iterable, copy existing binary data. They support mutable sequence operations in addition to the common ones. So appends X to the end of the sequence. Yeah, so why is that a problem? I'm not seeing why byte array dot append. Let's do it this way. Python byte array dot append. And what do we see? A Stack Overflow answer that will tell us everything. So really, is there an append all there that I missed or something? Extend. It's probably, maybe it's extend that I wanted there. Let's try that. Well, that's a whole lot of nothing. All right, well, let's uncomment that. Delete that. And extend. Okay, so we get a byte array that's the length of the message plus 4, and then we throw in that. Now again, there could be a better way to do this, but I'm pretty new to this whole operation here. Let's see, there seems to be an awful lot of zeros in this thing. If the first 4 bytes are 0, then we've already done something wrong, because the length of that message is almost certainly not 0. Right? But how would one go about this now? Struct.unpack, I suppose. It's going to take a value and go, right? Okay, so I don't know. Let's print, we can say data is equal to test encode, and then test decode data. We'll go ahead and maybe we'll do this. So if I save that, I get the output that I got last time. And what we actually want is to print struct.unpack and data. What does that do? Unpack requires a bytes object of length 4. Oh, man. Print len data. Whoops. That is not what I meant to do. I meant to save it. And its length is 56. We don't really want, for our purposes, to have to decode the whole thing at once. So let's say this. If there was a string like so, I guess I want something like that. Is the 0 implied? Looks like. Whoops. The console says 56. Let's get rid of that one for a second. Oh, sorry. That says 56. That says 0. Well, let's assume that in no way is this doing what I intended. So let's just do that. And print repr payload. Oh, sorry, I didn't want to extend it by the message either. See, this is where we are perhaps... That's a pretty big byte array. Which again, it's filled with null bytes. Okay, that doesn't do what I thought it would do. That should have been more obvious. I was thinking more capacity. Is what I was thinking of. So that probably makes a hell of a lot more sense. One of those things that's stuck in my head, why would you keep reallocating an object when you could specify exactly how big it's supposed to be? So, okay. So that's probably good. So let's say message length is equal to this. And then if we just quickly double check what struct.unpack returns, I assume a tuple, even if it contains exactly one. The byteframe must contain exactly the amount of data required by the format. Len bytes must be equal calc size. Okay, so Zush. In that case, message ID and val1 and val2 and len val3 and val3 bytes. I guess in this case I don't actually have to transmit the length because the bytes is going to encode as the appropriate size. So maybe that'll make life easier for us. We can just say val3 dot encode UTF-8 there and say string, and then we can modify those as so. Leave this one out. So we can say message ID 1, 2. That would just actually be val3, val4, val5 is equal to struct.unpack something and data, again, that. If x4 is that, then x5 colon is, oh no, x4 colon, because the offset is 0 based. So yeah, that's what I did there, right? I accidentally did what I was expecting to do. So it is big endian stuff. And I guess we use the exact same format string, don't we? Oh, actually, we have to redact that out. Say we are going to go HIIS question mark D, and then say a little of this. Whoops, I did that wrong. We'll do that. We'll do it this way. That makes more sense, perhaps. Print thus. Val3 is something we decode as UTF-8. And what do we see as the result in the console? We see 1822 character H. It's probably not what I expected. And then a true, and then 14.78. So except for how the string didn't come through, maybe I was supposed to put the size in there. For giggles, we'll start it like this. 1, 2, 3, 4, 5. Can I do this? Again, I may have made life harder on myself initially. Nope, done like that. Okay. But we still are only getting the first character, even though the rest seems to work. Which is interesting. I'm going to just do it this way. Well, let's do Python struct pack a string. I am trying to get a grip around the packing and unpacking of binary data. It's actually not that hard, except one problem. What if I have a variable length text string I want to pack and unpack in the most elegant manner? Does only support fixed length structures. For variable length strings, dynamically constructor format. Use the normal string methods to add. Unpack a bit at a time. See, again, the data seems to be packing in there properly. Well, I know that it must be encoding the data appropriately in there. I'm going to go ahead and again do print repr data. So we can see that it prints the first 4 bytes, that's that. I assume that it's doing the whole thing. Maybe it's not. There's the H, so only the 1, huh? So did I sort of have that right to begin with by encoding? How do I throw? Oh, it has to have a fixed length size in front of it. Okay. So let's go ahead and try that. I want to actually call the stream. We've been going for an hour and a half. Well, this thing seems to think, oh, I didn't actually start that. It's actually 9:30. Okay. Yeah. So I just want to get this part done just so that there's some coding in this thing. And this is indeed how this generally goes. So again, instead of an S, we're going to put %d, a big I, %ds, and mod that with the length of val3. Oh, again, we're going to say val3 is equal to val3.encode as UTF-8 to make sure that it's bytes so that it all works out the same. And here we can just say val3 I think that would kind of work, but will possibly break stuff. Expected 7 items for packing, got 6. Okay, so it. Oh, we need to nolen val3 like so. We can bring these back. Notice how I'm pedantic about my debug code being readable. What did that do? I did that actually. Okay, that actually encoded something. We can see the word hello world in there like so. And again, we can see those bytes in the data, I think. Yeah, there we go. Hello world and the stuff. So that's encoding it properly. Instead of this, here's where we're going to have some problems pulling it out of there. Because we need to know the size first. So I'm going to guess what you need to do is do those and the capital I. And okay, we want that, say, per se, but you want all of those up to the %d in here, which, as that thing was talking about here, I suppose you need to use calc size to figure out how big that part of the format would be so that you can unpack just that first part up to there, and then we would have the length and we could go ahead and pull the string out. But we're not going to worry about that tonight. We're going to call the stream here because we got, I guess, probably about an hour's worth of me fiddling around in here. This code here is, I will check this network code in after the stream that we have been working on. And that whole code is for use in figuring out the encode and decode in these. And then once that's done, we can create a couple of very simple protocol messages, flesh out this whole protocol message class to assume that we can create and destroy or create a message and then recreate an instance from that data, and then move on after that to the network code. And I chose to do it that way because I'm fairly certain I can figure out how to write the network code because I've done that before. But this stuff with struct packing is something that I haven't really had a lot of experience with. So we're going to go ahead and call the stream. Thanks for watching this second day of Devember. I'll check this stuff in after I finish the devlog. And subscribe if you want to see more and follow along. I never mentioned it anywhere, but I have the live chat turned off just for the purposes of Devember so that I can stream without having to look to see if there's any chat messages, because that might derail things, although clearly I can derail that quite a bit on my own. So thank you for watching. Subscribe, like this channel, my videos, other channels, other videos. Do all of the YouTube things. And also, have a sublime day.